Hi everybody, this is Miss Peachy from WCA Astronomy Astronomy B. We are in second semester and I'm just recording this video to give you a bit of a tutorial on an alternative, I shouldn't say alternative, but it's a replacement portfolio for you for the planets portfolio. So I'm getting rid of the portfolio that's in the lesson. I don't like it. It has you go outside and track planets for 7 days, which I'd love you guys to get outside and do a lot of like in-person astronomy, but it isn't realistic for everybody. We have a lot of students that live in cities. We have bad weather, and so it doesn't necessarily work well. Plus, they don't give you 7 days to do the portfolio, which doesn't make a lot of sense. So instead, we are going to be using our planetarium program, which allows us to do some tracking, but isn't in real life. It's using the virtual planetarium, which helps a bit. So we are going to be tracking 2 planets for 7 days, but those 7 days aren't going to be 7 consecutive days. They're going to be 2 weeks apart. Each day is going to be 2 weeks from the previous day so that we can get kind of a longer period of time that we're tracking those planets, and it allows us to see the movement a bit better from the planets. So you're going to pick 2 planets. You're going to pick an inner planet and an outer planet. So your inner planets would be either Mercury, Venus, or Mars, and the outer planets probably Saturn or Jupiter. Those are the 2 planets that we can actually see with the naked eye. The planetarium software allows us to be able to track like Uranus, Neptune, but it doesn't seem they're not as easy to track. And honestly, it's makes it a little bit better to use planets that you can actually visualize in real life. So I would suggest Saturn or Jupiter for the outer planet. So pick the 2 of your choice because it doesn't really matter. And then what you're going to be doing is you're going to be using the planetarium software to write down the date that you observed it, the time, and then the coordinates. And the coordinates we're going to be using are azimuth and altitude. And it's going to be easy because the program actually tells you the azimuth and altitude, but I'm just going to remind you what that is as well. So I have the program opened. Oops. Let's get that open here. There we go. I just bring it over to the screen, and I have it currently set for December, which it is not December currently, but that's what I'm setting it for. And you're just going to have to find the planet. So what I suggest is turning on the ecliptic. So if you go to settings, go to view settings, you can put the ecliptic line on. And the reason why I suggest that is because the planets are always going to be found on this ecliptic line. That's that pinkish reddish line. So you can see Saturn, Jupiter, Uranus, Mars. Those are visible at this time that I've chosen, right? So no other ones are visible. If I wanted to, like Mercury and Venus, you're going to have to pick a time that's closer to sunset or sunrise if you want to see Mercury or Venus. So I'm going to have to go back to like a time that's a little closer to sunset or sunrise. And now you can see that Venus pops up there. Mercury is there as well at sunset. So you can choose Mercury and or Venus. It's just a bit trickier because they're only visible for a very short period of time. So a safer bet may be to just make sure you pick Mars, especially since you should try to track the planet at the same time every 2 weeks. And if we go as far out as every 2 weeks for 7 different, that's 14 weeks essentially, um, it might be too big of a window to be able to see Venus and or Mercury at the exact same time. Well, you'd have to play with that a little bit. So I'm going to go back to the time that I had initially picked, which was just after sunset. And it doesn't really matter which time you pick, just make sure you know what time it is. And I'm going to track the position of, in this case, I'm going to do Saturn. So I have the coordinate system of azimuthal grid selected right now, and that allows me to see the coordinate system. And essentially, azimuth and altitude are kind of like longitude and latitude, but they are not a fixed coordinate system in the sky. So it's the azimuth is the distance around the sphere. So if you see here, the horizon makes up a sphere, a circle, right? And any circle is 360 degrees. So north, which we are facing south right now. I'm going to try to face north here. Whoops. Where's my north? Okay, there's north. So when I face north, like there we go. I'm facing at 0 degrees. And then as I move around my circle, east is 90 degrees from north. It forms a 90-degree angle. South is 180 degrees from north. West is 270 degrees from north. North is 0 and or 360. They're the same coordinate, right? So that is your azimuth. So when we look at a planet, it has some degree around the circle. Altitude is going to be the height above the horizon. Whoops. This is so temperamental sometimes. So the horizon represents 0 degrees, and the zenith of the sky, which is the very top of the sky, is 90 degrees. So altitude is between 0 and 90 degrees. So when we look at Mars, we would say it has an azimuth and an altitude, some distance around the circle, and some height above the horizon. Now, I could make you use the coordinates at the top here, and they're kind of hard to see on here to determine the coordinates of Mars, but actually all you have to do is click on Mars, and then this little window pops up, and it says as/alt, and that's what we're going to use. And you're just going to pick the nearest kind of whole. Well, in your graph, or in your chart, you can write the exact number, the nearest degrees, 71 and 17, say. And that's what I'm going to write in here. So I would put planet name, Mars, day 1. I would put the date and the time here. So the date is it is December 2nd, 2022, and the time is 1810. And you can use that military time. That's fine, that 24-hour clock time. So 12/2, oops, and 1810. Okay, and azimuth we said was 71 and it's around 16. It changes because I said it's not a fixed coordinate system. So as the Earth rotates, the coordinate system changes too. That's why it's useful in kind of communicating the location of an object at that moment in time, but otherwise it becomes less useful as time goes on. So 71 and 16 I'm going to go with. So 71 and 16. Okay, so that's my example, right? And then what I'm going to do is I'm going to do the same thing 14 days later. So I'm not going to change this at all, guys. I'm just going to click up 14 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the date is 12/16. Everything else stays the same. So again, 1810 is still my time. I didn't change that. And let's look at the azimuth and altitude. So the azimuth is 83 and the altitude is 30. Azimuth of 83, altitude of 30. Okay, so that's just my example at this time, right? So once you've done all 7 days for your inner planet, then you're going to do 7 days for your outer planet. It would be probably good to do the same 7 days for each planet because then you kind of see if the day matters at all. I guess it doesn't really matter if you do the same 7 days. I didn't specify that, but it might be more scientific to do that. And then what you're going to do is you're going to graph it. So on the y-axis, we have altitude, and on the x-axis, we have azimuth. And you're going to put a number in the grid based on the day number for each planet, and you're going to have to get it to the nearest, the closest number. So 71 and 16 for day 1 for Mars. So 71 is your azimuth, so 72 is pretty close, and 16 is closer to 20 than it is to 10. So I'm going to put a number 1 here for Mars. I also want you to color coordinate that. So I want that number, like Mars will go with red, right? Red for Mars, and maybe I would do yellow for Saturn or something like that, just to make sure that we know which number series is going to represent each planet. And I want you to put them all on here, like all numbers 1, 2, 3, 4, 5, 6, and 7. Okay? Do that for Mars and do that for Mercury or Venus and do that for your second planet, either Saturn or Jupiter. Once you do that, you'll have two different sets of coordinates on here or two different sets of numbers on here. You're going to answer these two questions. It says use your finger or mouse. You're just basically going to trace the path that the planet moves on the grid. Maybe your numbers go 1, 2, 1, 2, 3, 4, 5, 6, 7 like this, and they're all going in one direction. Or maybe they're going like this way and then they come back this way and then they go this way again. So that represents two different types of motion. Some planets exhibit something called retrograde motion in the night sky. Does the planet that you tracked show retrograde motion? If the numbers go 1, 2, 3, 4, 5, 6, 7, like they go forward and then they come back again and then they go forward again, that's what's known as retrograde motion. If the numbers proceed in one direction, 1, 2, 3, 4, 5, 6, 7, that's showing a planet that is steadily moving um, from east to west through the night sky from night to night, and it's not showing that retrograde motion. So we're just trying to see is the planet they're observing showing retrograde motion or is it not showing retrograde motion? And then explain, does it matter if it's an inner planet or outer planet? And how do you explain the motion of the planet based on what you know about that planet's motion, about retrograde motion and what causes it? All right, so that is what you need to do for this portfolio. It is worth 15 points. I'm going to go ahead and delete the things off here that I put on because this is actually not the copy. Remember that this is not an editable copy. So when you do open this, you will have to go to File and make a copy to make your own copy, or then download this to Microsoft Word. Do one of the two things to make your own copy. If you have questions on it, let me know. Otherwise, that's all you need to do for this, ladies and gents, and have a great day.